See, I wrote one problem here. I want to apply Thevenin's theorem to find current I. So according to the given problem, find I is there. So find I. Then I want to apply here Thevenin's theorem. See, we can find this I using simple technique, total resistance technicals, because here 3 ohms and 3 ohms, these two are connected in series. Now it becomes 6, and again here 3 ohms resistor is there. This complete network is connected with another resistor 6 here, and the voltage source is here 24 voltage source. This is 24. This is a simplified network now. See, this is 6 ohms and 3 ohms. These two are in parallel combination. If these two are in parallel combination, the total resistance is here 2 ohms. The total resistance is 2 ohms. And again 2 ohms and 6 ohms both are connected in series. Then finally which gives the total resistance is 8 ohms. Applying general technique here, the source total resistance technique. So the total resistance is 8 ohms and total voltage is 24 volts is there. Then I want here total current I, total current IT here. Total current is equal to total voltage by total resistance, that is 24 by 8, then it becomes 3 amperes. So current through this branch is 3 amperes now. The current through this branch is 3 amperes, the 3 amperes is divided into two paths. One path is a 3 ohms resistor, another path consists 6 ohms resistor. Then we want current through this branch, this current is here I. Then applying current division theorem. According to the current division theorem, current through one branch is equal to total current into opposite resistance 3 by total resistance. We have to take only this path. So 6 plus 3 is here 9, then becomes 1 amps. So find the current I in a given circuit means we have to apply this technique, simple technique for objective, for multiple choice questions purpose, because it takes only 2 steps here. Just simplify this network and find out the total resistance. First find out total current, then from that current apply current division theorem, then it gives the 1 ampere. So now here I am applying Thevenin's theorem for this given network. Thevenin's theorem. I want to find I current using Thevenin's theorem. So here I want to explain how to apply Thevenin's theorem for the given network. That purpose I am applying for this network Thevenin's theorem. But your Thevenin's theorem is not compulsory for the given network, just this technique is enough here. So finally answer is 1 ampere is there. So now I am applying here Thevenin's theorem. According to the Thevenin's theorem, the complete network is connected in between open circuit load terminals. So the required network is like this. This is one linear network. This linear network is connected in between A and B terminals. Here A and B terminals is nothing but load terminals. Load terminals. Open circuited load terminals is required. Now in this network, a requirement is current through this 3 ohms resistor. Find current through this 3 ohms resistor. Determine current through 3 ohms resistor. Now this is acts as a load resistance. This is acts as a load resistance. Now remove that load resistance path, because our requirement is open circuit load terminals. Open circuit load terminals is required. Just remove this network, then remove this resistance, load resistance, then redraw the circuit. Now the circuit is like this. So voltage source is connected as it is. So from the Thevenin's theorem, it requires a linear network connected in between open circuit and load terminals. So this network is required. That's why first step we have to apply this procedure. Open the load resistance, open the load terminals. To open the load terminals purpose, here load resistor is eliminated, because according to the given question, find current through the 3 ohms resistor. So now this resistor is acts as a load. So load is eliminated. Now the circuit is acts as a open circuit load terminals. So here 3 ohms resistor, and here 3 ohms, and here 6 ohms is there. This is 24 voltage source. So now this is acts as a linear network. The linear network is connected in between open circuit load terminals. So open circuit load terminals. Now replace this complete linear network with Thevenin's equivalent circuit. The Thevenin's equivalent circuit consists one voltage source. Thevenin's equivalent circuit consists one voltage source and one resistance. Both are in series. So this complete network, Thevenin's equivalent circuit, is connected in between open circuit and load terminals. So now we have to replace this complete network with one VTH and RTH. So already explained VTH. VTH is nothing but voltage across. This is VTH. Voltage across open circuited load terminals. Voltage across open circuited load terminals. So now these two are opened. Voltage across those 2 points becomes here VTH. So VTH is equal to VOC. Open circuit voltage across the load terminals. Then we have to find out voltage across this point here. If these two terminals are open circuited, then the current through this branch becomes here 0. No current flows through this path because these two are open. If the current through this branch is 0 amperes, then the total current is flows through these two resistors. Total current is flows through these two resistors. One is 6 ohms, another is 3 ohms. So if the current is flows through this 6 ohms resistor and 3 ohms resistors are same current, then the two resistors are connected in series combination. Because in general cases, at this point current has to divide. At this junction point current has to divide this side and this side. But current through this branch is 0 amperes because this is open circuited. Then the total current is flows through this path. Total current is flows through this path. So then these two resistors are connected in series combination. 6 ohms resistor, 3 ohms resistor both are connected in series. Then we want voltage across these 2 points. So voltage across these 2 points is nothing but voltage across 3 ohms and voltage across 3 ohms. These two voltages. But your current is 0. That's why directly I am taking VTH is nothing but here. VTH is nothing but voltage across 3 ohms resistor. In general cases, this total voltage equal to this voltage plus this voltage. Summation of these two. But here current through this resistance is 0. So voltage across this 3 ohms resistor is 0 here. So this path is 0. Then we have to directly voltage across 3 ohms resistor. 6 ohms resistor, 3 ohms resistor, these two are connected in series. Then we want voltage across one resistor. Then apply immediately voltage division theorem. Voltage division theorem. Any two elements are connected in series combination. To find voltage across one element, voltage division theorem is used. So according to that voltage division theorem, total voltage into same resistance by sum of two resistance, because this current is flows through these two resistors, that is 9 here. 9. So now simplify this 3 and 3 and here it gives the 8 volts. 8 volts. So after simplification, Thevenin's voltage is 8 volts. Thevenin's voltage is 8 volts. So Thevenin's voltage is finished. Then we have to find out Thevenin's resistance. So already explained, to find Thevenin's resistance, two techniques are used, depends on the given network. So now go through the network. The network has only one independent source. If the network consists only independent sources, remove all the independent sources with internal resistance. Apply internal resistance. Here only one independent source is there, so first technique is enough. So apply first technique here. Voltage source is eliminated. So voltage source acts as a short circuit and remaining network is as it is. So if the network consists only independent sources, remove all the independent sources, directly find Thevenin's resistance between open circuit load terminals. It is also called as internal resistance. It is also called as internal resistance of the circuit. So 6, 3 and 3 is there. Now we want resistance between these two terminals here. To find the resistance between these two terminals, now these two are connected in parallel combination. After simplification, 6 and 3 parallel. 6 and 3 parallel means it becomes 2. 6 into 3 by 6 plus 3. And the remaining resistor is here 3. Now finally, in between A and B terminals, the total resistance is 5 ohms. In between A and B terminals, the total resistance is 5 ohms. So Thevenin's resistance is 5 ohms and Thevenin's voltage is 8 volts. Thevenin's voltage is 8 volts. Then replace this complete network with Thevenin's equivalent circuit. So this gives the Thevenin's equivalent circuit. Thevenin's equivalent circuit, which consists of one voltage source. Voltage source value is 8 volts. So you write 8 volts. And which consists of one resistance in series with the voltage source. The resistance value is how much here? 5 ohms. So correct here 5 ohms. So now finally this open circuited linear network, open circuited load terminals linear network is replaced with a Thevenin's equivalent circuit. So this comes under Thevenin's theorem. But according to the given question, find the current through the 3 ohms resistor is there. So current through the load resistor, then connect the load resistor here. So connect the load resistor in between open circuit load terminals, this is 3 ohms. Then we want current through this one here. According to Thevenin's theorem, the load current IL is equal to Thevenin's voltage by total resistance. Total resistance here R Thevenin's and RL both are in series, so now it becomes RTh plus RL. So load current is equal to total voltage by RTh, Thevenin's resistance plus load resistance, Thevenin's R source resistance. So RTh plus RL, then the total voltage is here 8 volts by RTh is 5 plus load resistance is 3, then becomes 1 amps. So the current through the 3 ohms resistor is here 1 amps. So here I explained the same problem using total resistance technique, then it gives the 1 ampere technique, 1 amp. So finally answer is same, the response is same here, but different procedures. Here applied total resistance method and here applied Thevenin's theorem procedure. So according to the competitive exams point of view, if the question is find I means apply this one. For academic purpose and find the current I using Thevenin's theorem means you have to apply this procedure. This is the standard procedure for Thevenin's theorem. So to apply Thevenin's theorem for any network. So you have to remember one point. That point is to convert Thevenin's equivalent circuit purpose, it requires open circuit load terminals network is required. Sometimes the expected question is directly open circuit load terminals, or sometimes the question is expected like this. For these type of questions, first we have to remove the load resistance and draw the network is completely open circuit and load terminals network, then convert into Thevenin's equivalent circuit. So this is the standard procedure to apply Thevenin's theorem. So please note on this procedure, and similarly we have to discuss some other problems on this topic. So now these questions are previous competitive exams questions. Now I want to solve these questions using Thevenin's theorem, Thevenin's or Norton's theorem. See here one problem is given like this here, which consists one independent source and one dependent source, and the voltage across A and B terminals is Vx is there, and this dependent source is current source, and the current source magnitude is depends on the Vx value. Dependent source this current source magnitude is depends on the Vx. Vx is nothing but voltage across A and B terminals, and two resistors, one is 2 ohms and 4 ohms is there. So now this is one given problem. Convert the complete circuit into Thevenin's equivalent circuit or Norton's equivalent circuit. That is our question now. So convert the complete circuit into Thevenin's equivalent circuit or Norton's equivalent circuit, or the simple question is like this: find R Thevenin's equivalent resistance in between A and B terminals. So now just I want to find out R Thevenin's for the given network here. See, to find R Thevenin's according to the given network, in this one independent source is there, one dependent source is there. So to find R Thevenin's, already explained, two techniques are there. One technique is, if the network consists only independent sources, just remove all the sources and find out the equivalent resistance between A and B terminals. But here the network consists one dependent source also there here. So if the network consists one dependent source, immediately we have to find out Thevenin's and Norton's current. So from that analysis, required analysis is like this here. RTh is, if the network consists one dependent source, so compulsory we have tried like this: Vth by Norton's current, or VOC, open circuit voltage by short circuit current. So now we have to find out open circuit voltage and short circuit current from the given network. So to find that purpose, first we require open circuit and low terminal. So already the given network is open circuit and low terminals is there. So directly we have to find out open circuit voltage across the low terminals. Here we have to find out VOC. Open circuit voltage across the low terminals is VOC, that is also called as Thevenin's voltage. According to the given network, VOC is nothing but Vx here. So according to the given network, VOC, open circuit voltage, is equal to Vx. So this is Vx is there. So now this circuit is open, these two terminals are open circuit low terminals. So current through this branch becomes now 0. because current through the open circuit is 0. So this current becomes now 0 amps. Then directly VOC gives the here. So this voltage is VOC voltage. VOC or Vx. According to this analysis, VOC is equal to Vx. Then apply nodal analysis there. So this current is incoming current. So minus Vx by 4. So this VOC is equal to, I am writing here, Vx. So minus Vx by 4 because current is incoming direction here, and current through this branch. Current through this branch explains the Vx minus this voltage. Vx minus 4 by resistance of that is 2 is equal to 0. Then simplify this here. So minus Vx by 4 plus Vx by 2 minus 4 by 2. So take LCM. 4 is the LCM. So minus Vx plus 2Vx minus 8 because 2 multiplies here. This becomes 0. Then 2Vx minus Vx, it becomes Vx. Vx is equal to 8 volts. Vx is equal to 8 volts. So according to the given network, Vx is equal to VOC open circuit voltage. Open circuit voltage is nothing but Thevenin's voltage. So from the given network, Thevenin's voltage is 8 volts. So finally we got Thevenin's voltage. Then what we required? Thevenin's resistance is required. So to find the Thevenin's resistance, VOC by ISC. Again we want here ISC, Norton's current or short circuit current. This is required. Norton's current or short circuit. To find this parameter, again redraw the network. Again here we have to redraw the network. So the network is like this. Here voltage source is there, resistance. So Norton's current or short circuit current. Norton's current or short circuit current meaning is the current through the load terminals, short circuited load terminals. So immediately we have to short circuit the load terminals, then find the current through this branch. This is ISC. If A and B terminals are short circuited, A and B terminals are short circuited, voltage across these 2 points is 0. So immediately it becomes Vx is 0. If this is current source, this current source value depends on the which value? Vx. Voltage across A and B terminals. Voltage across A and B terminals is here Vx. So if Vx is there, then this magnitude is Vx by 4. But to find ISC, short circuit current or Norton's current, short circuit these 2 terminals. If these 2 terminals are short circuited, voltage across these 2 points becomes 0. So indirectly Vx value becomes 0 here. So if Vx is 0, automatically this magnitude is also 0, because here the current source magnitude is depends on the completely Vx value. So if Vx value is 0, this current source value 0 by 4 is 0 amps. So the current source becomes here 0. If the current source is 0, then this source is open circuited like this. Because current source is 0, internal resistance of the current source is infinity, current source acts as open circuit. If the voltage source is 0, internal resistance of the voltage source is 0. So then the voltage source acts as a short circuit. But according to the given network, this source is current source. Now this is acts as a open circuit. So write that point clearly. If Vx is 0, if Vx is 0, dependent current source dependent current source is eliminated. Dependent current source is eliminated because this is completely depends on the Vx value. Vx is 0, this value is also 0, so current source acts as open circuit. These resistors are as it is same here, 2 and 4 is there, and voltage source is 4 volts. Then what we required? Current through the A and B terminal, short circuit current. So if this source is eliminated from the given network, it acts as a one simple loop circuit. In this loop circuit, what we required? Short circuit current, total voltage by total resistance. So total voltage is 4 and total resistance is 4 plus 2, 6. So now this gives the 2 by 3 amps here. So ISC is 2 by 3 amperes and Thevenin's VOC is 8 volts. Then Thevenin's resistance is VOC by ISC. VOC by ISC, VOC is 8 volts and ISC is 2 by 3. Now it gives the 12 ohms resistance. 12 ohms resistance. So finally we got Thevenin's resistance and short circuit current and open circuit voltage. Then the equivalent Thevenin circuit is one voltage source and one resistance. Both are in series. This gives the equivalent voltage source, equivalent Thevenin's equivalent circuit here. Thevenin's equivalent voltage is 8 ohms. Thevenin's resistance is 12 ohms. This gives the Thevenin's equivalent circuit. And similarly, if you want to draw the Norton's equivalent circuit, one current source and one resistance, these two are connected in parallel combination. Parallel combination. Now the Norton's resistance is 12 ohms because Thevenin's resistance and Norton's resistance both are same, and Norton's current is 2 by 3 amps here. 2 by 3 amps. So this gives you directly Thevenin's equivalent circuit and Norton's equivalent circuit. The question is here Thevenin's resistance. So Thevenin's resistance is 12 ohms. This is one standard problem. This is previous competitive exam question. The question is given, find R Thevenins. So to find the R Thevenins, compulsory we have to find out Thevenin's voltage, open circuit voltage and short circuit current. These two are compulsory here. And similarly, one more problem is given like this. Find out the Thevenin's equivalent circuit of the given problem. So this is another problem. This is another previous competitive exam question. The question is given here, find the equivalent circuit, Thevenin's equivalent circuit in between A and B terminals. See, to find the Thevenin's equivalent circuit in between A and B terminals, just I am redraw the circuit here. So again I am drawing. The circuit is like this. In between A and B terminals. In between A and B terminals, one resistor, one voltage source is connected, 3 and 8 volts. Similarly, in between A and B terminals, another resistor and one more voltage source is connected. This is 4 volts. So now the given network is like this. Then we have to replace equivalent Thevenin's equivalent circuit. So to find that purpose, initially I want to find out Thevenin's voltage, VOC, open circuit voltage, or it is also called as Thevenin's voltage. So this point gives the Thevenin's voltage. Thevenin's voltage or open circuit voltage. Then to find this purpose, I am applying here nodal analysis. So according to the nodal analysis, VTH minus 8 by 3 plus this branch VTH minus 4 by 7 is equal to 0. Is equal to 0. Then take LCM. 7 is multiplied here. 7 VTH minus 56 plus 3 VTH minus 12 is equal to 0. 7 and 3, 10 is there. So finally which gives the VTH is equal to by 10, and here 56 and 12. 56 and 12, 58 and 68 are, so 68 by 10 directly which gives the 6.8 volts. 6.8 volts. Now finally we got Thevenin's voltage, that is open circuit voltage. Then our requirement is Thevenin's resistance. To find the Thevenin's resistance, two techniques are there. If the network consists dependent source, apply this formula VOC by ISC. If the network consists only independent sources, then directly remove all the independent sources. Now the network has only independent sources. So remove all the independent sources. Those sources are voltage sources. So voltage sources acts as a short circuit. Now one resistance 3, and here it is short circuited. Another resistance 7. Two voltage source and voltage source both are short circuited. Then 7 and 3, these two are connected in parallel combination. Then which gives the Thevenin's resistance is, parallel combination is 7 into 3 by 7 plus 3. Then directly which gives the 2.1 ohms. So Thevenin's resistance is 2.1 ohms and Thevenin's voltage is 6.8 volts. So finally we got Thevenin's voltage and Thevenin's resistance. So this is the standard procedure to find Thevenin's voltage, Norton's current and Thevenin's resistance according to the given problem. So these problems are important problems because these are previous competitive exams questions. So please note down the solutions of the given problem.
Thank you very much guys for watching all the videos. So far what we have completed, let's discuss about it now. Over the screen you can watch SAIMEDHA.in app. If you open the app guys, you are going to see there. Let's talk about the store now in some other branch. Let's open a EEE branch guys. In the triple E branch you can see the content. In the content engineering, in the engineering we have electrical circuit, 75 videos there. In that mesh and nodal analysis, if you open, you can see there we are having around 11 lectures guys that we have completed. Then practice set 1, practice set 2 with solutions, questions with solutions, practice set 3, questions with solution, previous ESET questions with solutions, and at last we have what mesh and nodal analysis practice sets. So what we have covered guys, we have completed all the basic to advanced level video lectures. Then we have completed the practice set 1, set 2, set 3. Each set is going to have around 20 to 100 questions there guys, based upon the topic marks. It is going to be there in the not only in ESET but also in the government jobs and PSUs. And at last you have there an online test examination also, in order to check the time management what you need to utilize in the competitive examinations. So this is so far we have completed guys. Now you can watch over the videos. It can be utilized for, it is useful for not only the ESET examination but also for DRDO, sub engineer, assistant engineer, Telangana State Public Service Commission, Andhra Pradesh Public Service Commission, BHEL, NTPC, IOCL, Staff Selection Commission, JEE. I remind guys, for EC, EEE and civil, this SSC JEE will be there every year twice. So make sure you utilize all the video lectures to prepare for this examination also. And everyone knows about the Railway Recruitment Board Junior Engineer and as well as ISRO guys. If you people are interested to watch all the full length videos in the SAIMEDHA.in app, make sure you save this number. This is in charge sir Shashikant Valmiki sir number guys, 98486 92598. Give him a missed call, give him a call guys for any details, for any updates. Every single day we are updating the videos, material, and as well as what a competitive level examination practice set papers also. Thank you very much guys. I wish that you have watched all the videos. If not, if you haven't watched so far, go and refer all the videos guys. Thank you very much. This is Mohammad Inzamam signing off.